Hi everyone, my name is Adrian Kazigo. I'm the Solar Car Battery Lead, and Josh is the Battery Protection Lead. We will be working closely together to ensure the battery pack is in good functioning condition. So I'm doing this brief review to give you an idea of what the battery team is all about, to sort of give you an idea of what to expect if you decide to join the battery team. I'll be going through the roles and responsibilities of the battery team on the solar car project. Okay, so let's dive right in. So these are the topics I'll be talking about in this presentation. What does the battery team do? Lithium battery cell specifications, battery management system, also known as the BMS, parallel and series battery connections, spot welding, and soldering. Last but not least will be the battery case. What does the battery team do? The battery team is tasked with the responsibility of building the battery pack. The battery pack will essentially store energy from the solar panels and use it to power the motors and other electrical internal systems of the car. This is essentially the overall goal of the battery team. Now, the battery pack that we're going to be building has specifications, and these include the nominal voltage of 97.2 volts and a maximum continuous current discharge of 140 amps. The battery team also has a responsibility of protecting the battery using a battery management system, also known as a BMS. More on that later. Finally, the battery team will monitor and test the battery pack to ensure optimum working conditions. Now, moving on to the second topic, the lithium-ion battery cell specifications. We will be using 378 Panasonic Sanyo 18650 lithium-ion batteries. Each cell will have a nominal voltage of 3.6 volts, a battery capacity of 3,450 milliamp hours, a mass of about 50 grams, a maximum continuous current discharge of 10 amps, and a charge rate of 1.465 amps. Again, this is a brief overview. I'm not going into much detail here. If you're not familiar with any of the terms listed here, please send your questions via UCR Solar Car Discord channel, and we will get back to you as soon as possibly can. All right, moving on. The battery management system, also known as a BMS. I mentioned this earlier as I talked about the responsibilities of the battery team. I'll talk a little more about it here. The battery management system protects the battery pack from being overcharged or over-discharged, thereby extending the life of the battery pack. It does this by constantly monitoring every cell in the battery pack and calculating exactly how much current can safely go in during charging or come out during discharging of the battery pack without damaging it. It also calculates the state of charge by tracking how much energy goes in and out of the battery pack by monitoring cell voltages. This value can be thought of as a fuel gauge indicating how much battery power is left in the battery pack. So it balances cell voltages in the battery pack by intelligently bleeding off excess energy from cells that are charged more than others, thereby prolonging the life of the battery and avoiding premature wear and explosions. Moving on. Parallel and series battery connections. As I mentioned earlier, the battery pack will consist of 378 lithium ion cells, These cells will have to be arranged in a particular configuration to attain the desired voltage and current values. We will connect 27 lithium ion cells in series to form a string of cells. We will then connect 14 of these strings in parallel to get the required voltage and current values. The notation for this configuration is 27S 14P. So this means that we'll have 27 cells in series to make a string. Then we will connect 14 of these strings in parallel to get the desired voltage and current values. We can see how the math works out here. We have the cell nominal voltage of 3.6 volts per lithium ion cell. We multiply that by 27 cells and we get a nominal voltage of 97.2 volts. So this is the battery pack nominal voltage. Each string will have a maximum continuous current discharge of 10 amps. So we multiply that by 14 strings, we get 140 amps. Moving on. Spot welding and soldering. We will be using spot welding to attach the nickel strips that will be making terminal connections on the lithium ion cells. A spot welder primarily joins two or more metals together. This is usually achieved by melting two or more metals together. Moving on. We will also use soldering to make wire connections from the battery pack to the charger and discharge connectors. Now, soldering is the joining of different types of metals together by melting solder. The solder usually cools down to form a strong electrical bond with the metals it's joined to. Last but not least, we'll have a battery case for the battery, and it will be an off-the-shelf plastic box. It will feature a reservoir that safely captures material that may spill out of the battery pack. The plastic material is non-conductive and non-reactive. We will also have sealable airtight access ports for mounting hoses that will be attached to the intake and exhaust vents. This will allow for rapid cooling of the battery pack during usage. This marks the end of the presentation. Thanks for watching. See you next time.